Hey everybody, I was gonna make a video today about the quotient of the sine and the cosine, but I never got there because what was it again? Oh yeah, it's time for math with Mr. Troy. Oh, a tangent. I get. All right, everybody, this one should be super quick. We're going to set up our graph the same way we have before. We're going to call this pi and 2 pi. And let's just say 1, 2, 3. Okay, the tangent is the ratio of the y-coordinate to the x-coordinate. It is also the slope of the ray coming off the unit circle because the whole y over x is the slope formula thing. So we've got some places where it's really easy to tie into. Okay, we're going to actually start at negative pi over 2. Because at negative pi over 2, I can see that this ray is vertical. But what that means is that the tangent is undefined. If the tangent is undefined, that would show up as an asymptote on my graph. The next point I'm going to tie into is negative pi over 4. Negative pi over 4 has a tangent of negative 1. Then at 0, because the slope of that ray is 0, my tangent value is 0. At pi over 4, my tangent value is 1. And at pi over 2, my tangent is once again undefined. Now, we need to fill in the gaps a little bit here. I want you to think about what the slope of, say, this line would be. Looks like it might be 10. And this line might have a slope of, say, 8, 7, 3. Who knows? But the slope is getting more and more, or less and less as we approach, which is why the tangent parent function is going to be shaped like this. Now, if we hop over to the other side of the unit circle, we can see something interesting. When we go to just past pi over 2, we again have a very negative slope. So our graph is actually going to repeat. 3 pi over 4 has a slope of negative 1. Pi is 0. 5 pi over 4 is positive 1. So unlike the sine and the cosine, which have a period of 2 pi, this graph has a period of pi over 2. And that would look like this. Whoa! Pause the video to draw it, right, Troy? Okay, so that is what 2 periods of our graph would look like. I'm going to pause the video and do some movie magic and make that look a little bit better. Ready? Here we go. All right, there it is. Okay, some things to notice about the parent function here. 1. Our range is now from negative infinity to positive infinity, but our domain isn't. We cannot have inputs of pi over 2 or 3 pi over 2 or 5 pi over 2 or negative pi over 2. So there will be vertical asymptotes at all of the pi over 2s, pi over 2 plus pi n or n pi, as we say here, And we'll have x-intercepts at n pi as well. 0 pi, pi, 2 pi, etc. The graph is an odd function and has origin symmetry. So that is our parent function for the tangent. All right, here's a quick example. You won't have to do any of these on WebAssign until next week, but I thought it was nice to get out ahead of it. So we've got f of x equals the opposite of the tangent of x plus pi minus 1. I know that's an absolutely crazy pi. I'm not sure what font I'm using here. Maybe Web Squares. Maybe it's a Steve's font or something. Okay. So first thing to notice is that this function is shifted pi units to the left. Sorry, normally I'm used to pointing in one direction, which is the opposite of your direction, but now I'm in a camera and I'm not actually sure if this camera reverses stuff or not. Well, for me, it's that way, left. It's shifted pi units to the left from the parent function. Now, pi is the period, so that's actually going to make no difference. Just for this problem. We're going to be flipped upside down, and we're going to be shifted down 1. Now, we don't normally think of this graph as having a midline, but we can visualize that. And instead of going -1, 0, 1, we can think of it as low, middle, high, like we did with the sine and the cosine if we want. So, normally the graph starts at negative pi over 2. We can start this one at negative 3 pi over 2 just for the sake of argument, and then we'll figure out, that is not going to make a difference. So we've shifted pi units to the left. We start normally with an asymptote. Now, the way the graph would normally go is it would normally go 1 under, 1 on, 1 over, then an asymptote. But since this one is flipped upside down, it's actually going to start 1 above, on, below, asymptote, 1 above, on, below, asymptote. Now notice how I said that the fact that this was shifted pi to the left didn't make a difference. Notice how we're still centered on the y-axis. And our graph ends up having its asymptotes at the exact same place. And here's what our graph would look like. Believe it or not, folks, that took like 5 tries, and that's as good as they turned out. So, I did my best for you. Okay, like I said, this won't show up in a WebAssign. I just wanted you to see it before we started talking about it next week. Keep working on your WebAssign, and we'll have another video tomorrow. All right. I hope everything's going okay for you guys. Or people, folks. Hang in there. We are nearing the end of the school year. My goodness, it's almost time for summer. And who knows what that's going to bring. All right. See ya.